Hey, it's Jillian, and I'm going to go over what we just did, but with a check. Okay, so we're going to write up the check that we did orally last time. So here I've got 3x minus 5 equals 13. So you say out loud or in your head what the first thing is. We're going to bring over the... Okay, so we've got 3x here, and then we're going to bring over the negative 5, so it becomes positive 5. Then we're going to collect those two. Then we're going to divide both sides by 3, or if that's multiplying, you can then it's divided on this side. And 18 over 3 is 6. So now we're going to check to see if the left side equals the right side. And when you write up a check, you're going to do it exactly like this. You're going to write the word check, and then you'll write left side equals, right side equals, and then leave room so you can write out what the left side is, write out what the right side is, and then you're going to, sometimes there will be an integer on this one of the sides, sometimes there will be a place for you to plug in x equals, in this case 6, on both sides. It just depends on what's in the equation. Like if this said 3x minus 5 equals 13 plus x, then we would have x on this to also plug in. So let me plug in x equals 6. So that's, instead of 3 times x, it's 3 times 6 minus 5. 3 times 6 is 18. 18 minus 5 is 13. This is already 13. You can see 13 equals 13. And then the final bit you write is, therefore, left side equals right side. You may have a teacher that writes, instead of left side, right side, says QED, which is, I'm not sure if I'm going to say this 100% correctly, but it's quantum est datum, which basically is, in Latin, it means that which I set out to prove I have demonstrated. Anyway, your teacher will either want this or this, whatever they want, just do that because that's how it works, right? Okay, so now let's do this one, and then we're going to do a check also. So first we're going to expand. So we've got 3 times 3 is 9, and 3 times negative 2x is negative 6x. And then 2x minus 3. So I'm going to keep the x's on this side and the integers on this side. So you can see if it was on the side already, I kept the sign. If it wasn't, I changed the sign. It was the same sign, and then I changed it when I moved over. So this collects negative 6 and negative 2 is negative 8x, and this is negative 12. And then I've got x equals negative 12 over negative 8. So first I know negative divided by negative is a positive. I'm going to just put a positive there. You know, normally we don't put a positive, but you can if you want, as long as you then rewrite it. So I'll do that this time to show you. And then 12 over 8 reduces what goes into 12 and into 8. Well, 4 does. 2 does also, but you're looking for the biggest number that goes into both of them. If you don't notice it, then what will happen is when you reduce your fraction, you'll be able to reduce it again. So for example, here, I've got 4 goes into both of these, so 4 goes into there 3 times, and 4 goes into there twice. What am I saying? 4 goes into there 4 times. 4 goes into there 3 times, and 4 goes into there twice. So again, just to demonstrate, if you didn't think of the 4 going in and you only thought of a 2. So if we have this, and you're going to reduce it by 2, the negative times negative is of course a positive, and then cut that and divide it by 2, and that divided by 2, and then you can see, wait a minute, I can do that again. So then I divide that by 2, and I divide that by 2, and as you can see, you end up with the same answer. So whether you can see the largest number to reduce the first time, or if you do it in several steps, if you keep going until you cannot reduce any more, you will always, and you don't make any silly mistakes, you will always get to the answer regardless. And then of course here you'll notice I've written out the answer without the plus sign, because the proper way to write the answer is this without the plus sign. But if it helps you to keep track of remembering that you've dealt with the signs, write the plus sign first. So now I have to take this and I need to check. So I'm going to check. I've got left side equals 3 times 3 minus 2x, and I have right side that equals 2x minus 3. So let's see here. So I've got x equals 3 over 2. We're not going to make it 1.5. We're not going to make it 1.5. We are just going to use the improper fraction we were given. So let's see here. First I've got 3 times 3 is 9. And actually, let me sub it in first because that's really the proper way to do it. So here I've got 3 minus 2, and instead of x I'm going to write 3 over 2. Okay? And then I'm going to close the bracket. So now I've got 3 and then 3 minus, and what is 2 times 3 over 2? Well, we did this work previously. I'm going to just go down here and write something. So we've got 2 times 3 over 2. So we know that is the same as this, and we can then multiply the tops and multiply the bottoms and then reduce. Or what we could do is we could say, wait a minute, I notice that you can reduce here. 2 goes into 2 once, and 2 goes into 2 once, and 1 times 3 over 1 times 1 is 3. Okay, any way you slice it, you can go this way, you can go that way, it's all good. So here, this whole thing equals 3. So now I've got 3 times 0, which of course equals 0. So let's see what this equals when I plug in 3 over 2. So I've got 2 times 3 over 2 minus 3. We already did this here, so 2 times 3 over 2 is equal to, the 2's cancel, it's equal to 3. 3 minus 3 is 0, and there, of course, therefore, you have demonstrated that the left side equals the right side. Okay. That's how we want you to check stuff.